the same results. Now, let's do it with some real data. Okay, let's open an SPSS file and do it with some real data. Let's take 5 minutes, take a quick break, come back here, and we're going to dive into SPS and do it with a real. There's a file on Blackboard called NC Birth. I think it says mod because we actually reduced the size of the file to 800 people from about several, at least 5 or 10,000 or something like that. But this is all the births in well, in our case, 800 of the births in North Carolina during a certain year, about 10 years ago or something like that. It's on Blackboard. Okay, it's called ncbirthmod.sav. It's an SPSS file. If you download it, you can just double, or even from Blackboard, if you double click on it, it'll open SPSS for you. Okay, if it doesn't, you can always take the route we did before. We just go to SPSS and go to File, Open Data, and navigate to the file and say open it. SPSS is a little slow sometimes on opening files, as you can see here. Okay. Now you notice while we're here, you may have noticed that the first thing that popped up is my output file. And in my output file, it typed in for me the syntax using SPSS's programming language. It typed in the syntax for doing exactly the process that I did using the menus. In other words, if you wanted to open this file, this is exactly what you would type in, get. Then it would describe the file location and name. This might be of some importance because when you're using R, if you're interested in R, this is the kind of thing you might actually be typing in from scratch. Or unless you're using the graphic user interface, some of the functions you might be able to use very similar to the SPSS. But you're going to be doing more of that with R. Now, you might want to save this because you might want to, as time goes on, learn about the syntax language. Well, if I can do it from the menus, why would I want to learn the syntax language? Well, since you're epidemiologist, in the future, you may be collecting data where you collect the data one day, you may have to merge it into a larger data set. Another day, merge it into a larger data. You may repeatedly be doing merging data in, repeating calculations, and so on and so forth that you do over and over again. You might want to be able to program those processes using the syntax language so you don't have to go through a laborious process of actually importing the data and merging it and so on and so forth. Allow it to write a program actually to do that and do your analysis each time it needs to be done. So at any rate, but that's why that output table pops up. Now your data set is displayed, as I said, very similar to a spreadsheet, except this is more of a database. Each row represents a subject, a person. One may represent male, one may represent female. We don't know at this stage, do we, just from looking at this? MAge is the variable name for the third column. That represents, of course, we can probably figure that out, it's the mother's age, right? This mother number 6 was 28 years old, number 7 is 25, and so on and so forth. Now, it would be interesting for us to know which one of these numbers, 1 or 2, represents the sex of whether male or female. Of course, we're talking about the infant, right? The mother's always female, presumably, right? So, what gender that the baby was. And then we have marital status, we have the race of the mother, we have whether or not the mother was Hispanic, how much weight the mother gained, how much, whether the mother smoked or not, whether the mother drank during pregnancy. This is that's how much weight the mother gained. This is the weight of the baby at birth in ounces, the weight of baby birth in grams. A low birth weight, that would be a premature baby, and that would be babies that were less than a certain number of ounces or grams at birth, or that were low. And these would be premature babies, maybe even a lower threshold for that. And the ethnicity of the mom, that's another way that they sorted the ethnicity. Now, if I click on this little box at the bottom that says variable view, I can go to the variable view, and there were 15 columns in the data view. Now I see 15 rows, one representing each one of the columns. So if I go into MAge, mother's age, I see it's a numeric variable. Sometimes you may need to check this and correct it if it's incorrect, if SPSS misinterpreted. If I go into sex, the sex of the infant, notice it's got a label that says sex of the child. age is sex is not a very good description if you were going to put it on a table or a chart that you wanted to use somewhere else. So what SPSS will let you do is have a very simple variable name, but then when the output is created, it'll let you have a much more complicated or descriptive label that's used on the charts and graphs instead. So that's why you have label. Instead of age, it'll have age of the mother in years. Much more descriptive, much more useful to us. Now, as far as the values are concerned, if you have a nominal variable, it'll give you the opportunity to put in a value for what each number represents for that variable. And that's going to be here under values. Notice if it's numeric, there's nothing there. Mother's age, there's none. But if it's a nominal variable, like for instance, gender or sex, well, there is something. If I click in there, there's a little gray bar to the right of that. If I click on that, it'll show us that 1 represents male and 2 represents female for the gender of the baby. Okay, if I look at some of these others, the smoking. Okay, I click in there under values. Let's see, 0, mother did not smoke during pregnancy. 1 is mother did smoke during pregnancy. Okay, and so on and so forth. So you can go through this on your own and tinker with them and so on and so forth, examine them a little bit more. I'm going to go back to the data view. I don't have to go back to the data view. It's just a little easier for me. By the way, if you feel uncomfortable looking at the numbers instead of what the numbers represent, numbers are nice to use because they're simple to enter instead of typing in male or female, which could be lowercase, uppercase, misinterpreted by the computer because it's not, there's a case issue or something like that, or typing issue. The numbers are a little bit more accurate and easier to enter. But when you put in that value to identify them, you can actually display them with that value if you want. You can go up to View, and if you look under here, there's something called a value label, which is not checked. If you click on that, it will become checked, and you'll actually be able to see the values instead of the numbers that you actually entered. Okay, so I'm going to leave it like that for whatever purposes that we might have. And I'm going to go ahead and do some calculations. Now, on Blackboard, you'll notice that there's a PDF file. Oops, I'm sorry, I opened the wrong one. There's a PDF file called, where is it? Exploring Data with Graphs and Numerical Summaries, Fall 2014. It sounds like something from elementary school, right? So at any rate, so if you look at that, you'll see that we're going to go through exercises that are similar to the ones that you see in here. In other words, this will show you the sequence of events, the sequence of selection of menus that I'm using to do various things. Like for instance, right now, exploring categorical data. We're going to look at categorical data and for instance, whether the mother smoked or did not smoke during pregnancy. And we're going to use the analyze drop down. We're going to choose descriptive statistics. When you do this at home on your own, if you look at this at home on your own, when you look at this document, I'm going to kind of put it away and just play on my own. When you look at this document, you'll be able to recreate what we're doing in class here, perhaps even in a little bit more detail if I skip something or something like that. So I'm not going to bother to keep this open because it's going to be kind of hard for me to look at it and do this at the same time. But you might prompt me a little bit. But I'm going to start out with categorical data. In other words, I'm going to variable view. SPSS calls it nominal data. If I click in here, you'll see you only have 3 choices: nominal, ordinal. We learned about that last week, and scale or scale data or numeric. In other words, for scale or scale data is numeric data. Okay, so plurality is nominal and so on and so forth. Plurality is the number of children born of the pregnancy, 1 or 2, whether it's twins and so on and so forth. Actually, that's numeric. I could actually change that to scale since it's a numeric variable. Okay, and because they didn't assign any values to it, not 1, 2, 3 children, something like that. So you can go back and adjust these if you need to. But gender, whether or not the mother was smoking and so a smoker and so on and so forth, smoked during pregnancy, those are nominal variables. Okay, so what kind of statistics do we use for nominal variables, right? Frequencies, right? So let's go down here, analyze descriptive statistics. We're not going to go to descriptives because, for instance, if we're talking about the gender of the baby, right? Then male and female would be two different categories, right? It would not make any sense to find the average of 0 and 1 for male and female. This has no meaning, right? So I'm going to click on descriptives. I'm sorry, frequencies instead. And I'm going to move the, let's see, marital status into my variables. Maybe not. Let's stick with smoke because I think that's what I did on that document. Smoke during pregnancy, right? They either did or they didn't. Notice has those little red, blue, and yellow balls. That indicates it's a nominal variable. Okay, so I click on statistics. I could do all this kind, but it really doesn't mean anything here because we're dealing with a frequency. So I'm going to see chart. Let's see. Let's say chart for a chart. Let's ask it. We might as well ask it to do these things for us in advance. Notice when I clicked on bar chart, it gave me the option of graphing it by frequencies, the number of people in each group, or by percentages, the percentage of people in each group. You can choose which one you want. I'm going to click OK, and I'm going to click OK again, and the output window is going to come up, and it's going to break this up into different groups. Mother did not smoke during pregnancy, 684 is the frequency, and the percentage is 85.5% of mothers. Mother did smoke during pregnancy, 114 mothers, 14.2%. Okay, and here's a bar chart that illustrates the difference. It's a lot easier seeing a bar chart than it is otherwise, right? So there's a bar chart that illustrates the relative rate of smoking or not smoking during pregnancy. Okay, so now if you wanted to make this chart up without going to SPSS and doing the calculations for the other data, the frequencies, there is a graphing function here. I'm going to click on graphing function. There's a number of ways to do this. There's something called chart builder. It's kind of a macro. There's something called graph board template chooser. That's another kind of automated way of doing it. There's also something called legacy dialogues. And since I'm an old geezer and I'm kind of a legacy, I like to use legacy dialogue. Right? So I'm going to go into legacy dialogue. And instead of bar chart, another way of displaying, just for the change, another way of displaying nominal data is a pie chart, right? Because it's just percentages anyway. I'm going to click pie chart. And it's going to ask me, do you want to summarize for groups of cases or for separate variables or individual? Well, I think it's separate, groups of cases, I guess it is. I don't remember now. Let's click that and see what happens. Okay, so the variable of define slices, but I don't think I'm in the right spot. But I'm going to move that in here. Let's see. Smoke. Number of cases or percentage of cases. I'm going to say this time percentage of cases. Okay, well, let me move that in there. Let's see if it'll do it. Oh, it did it. What do you know? Okay, so you'll be able to backtrack when you see this online to see what my selections were. Let me do that again. Graphs, legacy dialogues, pie chart. I really don't make many pie charts on here. That's why who wants? Nobody really uses these things. Summaries of separate variables might give you the opportunity to split it up. For instance, if I wanted to break this up into mothers that smoked that had male babies or female babies, I could factor this in. I don't think you're likely ever going to have to do that with pie charts, so I'm not going to bother with that. So I could have easily gone to legacy dialogue, the graphs and legacy dialogues, and done a bar chart. And in this case, a simple bar chart. And the variable I'm going to use is going to be maybe this time marital status. We click that in, move it into the category axis. As soon as it has the minimum, this time I'm using number of cases. As soon as it has the minimum amount of information it needs to go ahead and do something, notice I haven't given it a title, they're going to the other options. I'm going to click OK, but it's got enough to at least. What did I use again? Marital status. Okay, and 535 of the women approximately were married, and 275 of them were not married. Okay, simple bar charts. Okay? And that's what we do with frequencies in general. But again, the charts are more informative than the tables are frequently, at least in terms of demonstrating the data. So you could, when you are writing a report, for instance, in another class, or doing homework in this class, you could say to yourself, well, they're asking me about this particular nominal variable. So I want to describe this nominal variable. So to describe this nominal variable, I can do a number of things. I can, for instance, I can take this table with the actual numbers and I can highlight it and say copy. And then I can go to my Word document or whatever I'm using and I can paste this table into that document. Bingo. There it is, part of my report. Notice that it pasted in the labels so they're more descriptive. The only thing with this is that, you know, these kind of tables, when I click into it, look how complicated this table is. So if it's really wide, it gets pretty ugly. If it's really narrow, it's kind of hard to readjust all these weird tabs and stuff like that. So sometimes I find that it's better to take the table, copy it, and then when you go to your Word document, instead of saying paste, and remember, if you're using the ribbon, it's also, there's a little drop arrow next to the paste command in the ribbon. Okay, I don't have that on here. I choose paste special instead. Paste special now gives me more options. I can paste it as a formatted text file, which is what this table is right now, or I could paste it, and it didn't let me do it. Where is it? I wanted to paste it as a picture. What's that? No, you can. It should be able to copy special, I guess. No, see, it was already set up for all three, so it should have done it. But let me try now. Still not there. I don't know. Maybe it's a bug or something like that. Maybe my Word. But it should let me paste it as a picture. Pictures are nice because when you paste the picture, you can resize them, move them around easily. The downside of pasting as a picture is you can't go in and edit the numbers, like highlight a number or something like that. However, if you double click into any of these boxes or into any of these charts, you have the opportunity to edit this stuff, make it bold, select something, make it bold, change the color, type in, change the text in some areas and so on and so forth. So you can edit it in SPSS output rather than edit in the document itself. And it makes it easier. Now, I know for sure it should let me copy and paste oops. You want to save the changes, cancel. And paste. Whoops. See what happened with that table? Kind of weird, right? Let me get a new document. Okay, I'm going to take one of these tables. I'm going to say copy, and I'm going to say paste, special, and again, well, let me tell you, I think there's something wrong with my SPSS installation. I just got it in this new version. I just got it installed today. Got the serial number in there. I think there's a bug. Trust me, it should have shown me an option of pasting as a picture instead. But anyway, you'll be able to do that on yours. But there's apparently a bug in here on mine, and I'll get it worked out. Okay, so at any rate, let me move on. I'll close that. Okay, so now next, what about numerical variables? I want to be able to do the same kind of thing with numerical variables. I'm going to analyze descriptive statistics. What numerical variable do you think you guys might be interested in examining? Weight of the baby? Baby's weight? Okay, let's take a look at that. Descriptives. I'm going to go into descriptives now, and the variable I want to work with is going to be the weight of the child in ounces. Okay, now options, I can choose to find the variance, the range again, and so on and so forth. I'm going to say continue, and I'm going to say OK. Let's see what it does for us. Well, it gives us our descriptive statistics. It gives us the mean, gives us the standard deviation. So now, just from those two numbers, we know so much more about this distribution. Is this distribution normally distributed? What would be a good, fast way for me to get a rough idea of whether this distribution is normally distributed? Well, how about something even simpler than that? How about making a histogram and seeing if it looks normally distributed? Right? Let's go up to graphs, legacy dialogues, histogram. Okay, and for the variable, let's move in the weight of the child in ounces. Okay, and I'm going to click OK. See what the histogram. Oh, there's the histogram right there. In a moment, it created a histogram for 800 weights. Right? Does it look normally distributed? It's skewed which direction? Left, negatively or left, right? Why would you, well, that's kind of obvious. Why would I think it's kind of obvious that weight of babies at birth would be skewed to the left? It's not as, it's unusual to get a baby that weighs twice as much as all the other babies. But it's not, unfortunately, not that unusual to get a baby that weighs half the weight of all the other babies. Right? So it's kind of, if you think about it, it's not surprising it's skewed to the left, right? So the median is going to be in one spot, and the mean is going to be to the left of it because it's pulled down by the weight of the premature birth. Okay? So now I got a quick look at what this distribution looks like. So let's get some more information from this. I'm going to go to Analyze. I'm going to go to Descriptive Statistics. This time, remember on the other data we looked at, we could tease out a little bit more information by going to Explore. Okay, now notice I got some extra boxes. This time I'm going to be able to do them because I have multiple variables. I'm going to take a look at that variable again, the weight of the child in ounces. I'm going to put that into my dependence list. That's what I'm going to do my work on. Statistics, I'm going to find the 95% confidence intervals and so on and so forth. Why not find the percentiles too? That sounds interesting. Now on the plots, I'm going to say, hey, go ahead and make a histogram for me. Okay, again, okay, except this time, I don't want to know the weights of the child, the statistics for the weight of the children at birth. I want to split it up into two groups. Let's compare the weight of these children at birth for mothers who smoked during pregnancy and mothers who didn't smoke during pregnancy. And the way I do that is I want to break it up into two groups. That's called factoring, right? Math, when you factor something, take a number and break it up into its components. We're going to break this data up into its components. And the data that we're going to break it up by is the mother's smoking status. So I'm going to click on smoke during pregnancy. I'm going to move that into my factor list. And then I'm going to click OK. And what it's going to do is it's going to calculate all this for me. What was the average weight at birth for babies born to mothers who did not smoke during pregnancy? Is 117. Mothers who did smoke during pregnancy, 109. There's a difference there, isn't it? Right? That difference might be due to chance, because remember, if you got two groups, and you got two numbers, they're not going to be the same, right? You're not going to by accident or usually have a situation where this group, mothers who smoke 109, those who did smoke 109. Even if there's no difference, just by chance, there's going to be different numbers. So is that difference due to chance, or is that difference due to a real difference between the weight of babies at birth from mothers who, the whole population of all mothers who smoked or did not smoke during birth? How do I tell whether or not that's due to chance or not? Anybody got a guess? Yes. The standard error is related to standard deviation, which is related to the variability. So the more the variability is, the less easy it is to tell whether or not it's due to chance. But you want to know something? The real answer to that question is I can't tell just by looking at this. I have to do other kinds of calculations. I have to understand the data. That's what statisticians do. That's our job for the rest of the semester, is to figure out when we see these differences, how sure am I that those differences are due to a real difference in the exposure, a real difference in the intervention, a real difference in the placebo versus the drug? How do I know that difference is real and not just due to chance? Because my two groups are going to get different numbers anyway. That's it. That's what we do. That's what we're going to do all semester. We're going to find 100 different ways to do it. right? But that's important. That's what this is really all about when we come to the end. But look at all this information that we got here just quickly with SPSS. There's our histogram again. It is shown behind me, right? There's a histogram. Every once in a while, I got to force myself to look back. Except this time, not only did it do it for all of the children, but it did it. It should have done it. It did it for this first one is for mothers who smoked during pregnancy, and then the one below it is mothers who didn't. This is a little blockier because the number of mothers who smoked during pregnancy was a smaller value. There's our stem and leaf plots, which really kind of mimic our histograms. And look what else we got here. We got our box plots as well. Side-by-side box plots for mothers who smoked and mothers who didn't smoke. Now, you'll notice that there's a lot of outliers. And that's kind of expected, right? Because remember, we have those premature births, and a lot of them are considerably below the weights of the main group of normal babies, right? So those all came up here as outliers and stuff like that. So we may want to include that data. We may want to find some other way to look at it and stuff like that. But this is pretty informative, right? I mean, I see a little difference. It's not an enormous difference, though, is it? Right? So maybe the differences are due to chance. We don't know yet, do we? Right? So we'll figure that out as time goes along. Okay, so now, let's see if there's anything else that I wanted to show you on here. Graphs, analyze. I think that's okay. So this basically is what we're going to be doing for the rest of the semester. And I did make up an exercise here, which is we're pretty much within about 8 minutes of the end of the class. I did make up a little exercise here that you may want to get started on now and take home with you. I'm going to post the homework probably by tomorrow morning. Now, the homework is going to be accessible through Blackboard. You'll see under assignments, you'll see a link to the homework. And the homework will take you to an area where you'll have the problem and give you an area for each question where you can either answer it by checking off multiple guesses or true, false, or something like that, or entering the numbers, the product of what you're doing, or so on and so forth, even uploading a file in some cases. But you'll actually do it on Blackboard. You'll upload your answers on Blackboard. When you're ready, you can stop, you can go back to it, stuff like that. When you're ready, you can click submit. And up until the time you hit submit, you'll be able to always go back there and play around with it a little bit. And in fact, I'm going to make sure that you can, up until the time that it's late, you can submit it multiple times and stuff like that. So if you want, I'll make it so you can submit it twice, right? Once you can submit it once. If you submit it early, like the first, I think most likely that this is going to be due. I'm not sure. I have to talk to Levi in either a week or 2 weeks. If it's due in 1 week, if you do it before Friday, I'll look through it and grade it, and then you can submit it again if you want. Okay, if it's due in 2 weeks, I'll wait until Monday or something. We're gonna do 2 weeks. Yeah, I think it was 2 weeks. I don't remember right now. Yeah, but I'll post the date. So you got two homeworks. One is this exercise. Do this exercise. Copy and paste the data into the exercise that's there. It's basically what we just did right now, except for different variables. Copy and paste them in, and upload that to a place I'll give you under assignments, and then answer the additional questions that are there. That'll be the first homework. Okay, I don't think you'll have any. Once you get used to doing it through Blackboard, it's really easy. I think you'll find it, actually a lot more convenient than dealing with a lot of different files and junk like that. Okay, so I'll post that. But if you look, there is a file on Blackboard called, let me find it here, Descriptive Statistics. Where is it? In-class exercise, September 15, right? And if you look at it, that's what it looks like. Here, it's on Blackboard. It's up there, I think, with the top group. It's there, right? Can you see it there? It's under lab. It's under the lab. Yep. It's in the lab. It's one of the documents that I'll show you right now. Am I wrong? Is it not there or is it there? Hang on a second there. Go into lab. You click into the folder for session 2, today's session 2, right? If you click into that folder, okay, if you look there, in class exercise, September 15, I'll click it, it's going to open it in a Word document. Right, there it is. And what does it ask you to do? Open the North Carolina birth data. Use SPSS to calculate the number of the mothers that smoke or don't smoke. I wound up doing that whole exercise for you anyway, practically, right? Age of all the mothers. Oh, actually, this time it's the age of the mothers for the second part. And then the calculation for the side by side, his box plots and so on and so forth, is the age of the mothers factored by smoking status of the mother. It's a little bit different. Yeah, there'll be a place where you can upload the file. Right, so you're basically going to copy those boxes, the chart or the graph, into this save the Word document and upload the Word document, not your output file. Okay, so trust me, you'll get the hang of it, but just do it with your Blackboard. The other thing is that please, if you email me anything, and you should do the same thing with, I've been trying to go along as you've been emailing me the city program certificates, updating it in there that you've added it. Okay, but if you email me stuff, it's better if you go to assignments, and in assignments you'll see a location to upload your certificate. It's better if you do it there. You may see I've already credited you for it if you emailed it. But the other thing is that if you email me anything, please put PH751 somewhere in the subject, so it doesn't. I have it programmed so it routes all of those into one box, so I don't miss any of your emails, because I get a lot of emails. It's very easy, and a lot of times your name, the return address, your email address is Red Aurora 97, and I don't know who that is. So it's not always obvious. But if you put PH751 on there, I know a lot of you don't necessarily use your hunter email address, but if you PH751, make sure I'm okay, so you might want to get started with that exercise now if you want to hang out here for a little while, or you might want to just go to hell home and say, I've had enough of this stuff. I can understand either one of them. I'm sorry, it'll be up by tomorrow morning. Yes. Yeah, the in-class exercise will be half the assignment, and this homework that you see on Blackboard will be other half. Okay, do you have any, I'm sorry? The homework, the lab is part of the homework. That exercise part of the homework assignment. It's a little bit different than what we did right now, but not so different that I think you'll be confused. Anybody got any major questions? It seems pretty, right? Seems okay, right? Not too bad. All right, and this video will be up by maybe about Tuesday night, right? Because I have to do a conversion. Okay, so hopefully the video will work, and I'll have a little bit more luck than we had with Google. We pay for this. Google's free, and as they say, you get what you pay for. Okay, guys, thank you very much, and good night.
Oh, that's done.